All right, so let's go looking for a rectangle. To go looking for a rectangle in neutral geometry, we're going to talk about how the following statements are all equivalent. And we're going to prove that 1 implies 2, and 2 implies 3, and 3 implies 4, and 4 implies 5, and 5 implies 6, and 6 implies 1. 6 implies 1 is the easy one. We're going to talk about why all those things are true. And basically what we're going to establish is if defect is 0, then there exists a rectangle. And if there is a rectangle, then defect is 0. And again, if the defect is 0, then the angle sum of a triangle is 180. And if the angle sum of a triangle is 180, then we are in a Euclidean geometry. The really crazy thing is if there's any triangle in your geometry whose defect is 0, then every triangle in your geometry has defect 0. So let's play this out. If there exists a triangle whose defect is 0, how do we know there exists a right triangle whose defect is 0? So we play the game. We assume that we have a triangle whose defect is 0. We take the vertex of the largest angle in the triangle and we drop an altitude. It can be proven, there's a lemma in your textbook, that if you take the largest angle of a triangle and drop the altitude, that foot of the altitude must be on the segment to which it is drawn. It's not on the line containing the segment, it is on the segment to which it is drawn. So that's what we do. Now, the defect of the whole triangle, of triangle ABC, is 0. And we know that defect is additive. So we know that this must have defect 0, and this must have defect 0. Defects are non-negative and additive. So the only way to add two non-negative numbers and get 0 is if they're both 0. So if triangle ABC has defect 0, then there exists a right triangle. In fact, there exist two whose defect is 0. So now, what if there exists a right triangle whose defect is 0? So there exists a right triangle whose defect is 0. This one right here, defect is 0. Take that triangle and copy it on the other side of the hypotenuse. Take that triangle, copy it on the other side of the hypotenuse. Well, it's not terribly hard to figure. This must also have defect 0, so both of these have angle sum 180. And if both of these have angle sum 180 and the triangles are congruent, whatever angle is here with measure alpha must also be here with measure alpha, and whatever angle is here with measure beta must be here with measure beta, but we know that alpha plus beta plus 90 is 180, so alpha plus beta is 90, so alpha plus beta is 90, alpha plus beta is 90. This quadrilateral is a rectangle. Once there is a rectangle, are there arbitrarily large rectangles? Sure there are. Once there is a rectangle, you can stack it out this way, you can stack it out this way, you can play them like dominoes. And what do we mean by arbitrarily large? We mean that we can make the sides of the rectangle bigger than any number we want. And that's true. How big do you want to make the base of the rectangle? Do you want to make it 11d12? Great, we can make it 11d12. Do you want to make it shinty 6? Great, we can make it shinty 6. We just pile up enough of these congruent rectangles to do the job. That is a strictly Euclidean idea. It is based on this idea of defect being 0. Well, once there are arbitrarily large rectangles, How do we show that the defect of every right triangle is 0? Well, we do that by saying, okay, let's imagine that we have a right triangle, any right triangle. We'll show that its defect must be 0. Because there are arbitrarily large rectangles, there is a rectangle that is bigger, whose sides are bigger than the two legs of our right triangle. So we enclose our right triangle, we stick it in a corner of an arbitrarily large rectangle. The rectangle has defect 0, and it can be broken up into smaller pieces, triangles. But the defects of these triangles are additive. They are non-negative and additive. So the defect of a rectangle is 0. So the defects of each of these triangles is 0. And so the defect of this triangle is 0. And if the defect, need another color, if the defect of every right triangle is 0, how do we show that the defect of every triangle is 0? This way. Every triangle has some biggest angle. Take that biggest angle, drop a perpendicular. Those defects add. And the defect of each of those right triangles is 0 by assumption. So the defect of the triangle is 0 by additivity of defect. And once the defect of every triangle is 0, then there exists a triangle whose defect is 0. Once you give me a triangle whose angle sum is 180, there are rectangles. And once there are rectangles, every triangle has an angle sum of 180. So we start to understand some of the things that are peculiarly Euclidean about our geometry. Hope this is helpful to you. Time for you to play around with Sakari quadrilaterals and Lambert quadrilaterals. The next video is going to describe Sakari quadrilaterals and Lambert quadrilaterals. Looking forward to it.